Sine squared and cosine squared is 1. What's 1 over sine? All right. And I believe the book assignments actually have you prove some of these other trig derivatives. And so you'll see how these rules look and how these rules work. But you can prove each of these with the quotient rule. And we proved, at our meeting on Friday, we proved tangent. Here's the proof of cotangent. And so here are those rules. Remember, derivative of sine is cosine, derivative of cosine is negative sine. But then we have derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant x you can show and you can prove is secant x tangent x. And derivative of cosecant x is negative cosecant x cotangent of x. The way you can remember these rules is that if you add a co to the function, you got to add a co to the derivative function and make it negative. So derivative of sine was cosine. Derivative of cosine is going to be negative sine. Main one is for these. Tangent is secant squared. So when it's cotangent, you make it cosecant squared and make it negative. Secant x tangent x, if it's cosecant, we're going to say that it's cosecant x cotangent x and make it negative. So very similar rules. All right. So we'll do it. Great, we did it. Go us. We read what was on the paper. All right. Let's make it more interesting. X minus tangent x. Well, derivative of x is 1. Derivative of tangent is secant squared. Next one's a product rule. Now we're getting more interesting. We're combining these rules and ideas here. So x secant of x. That's going to be first times derivative of the second. Derivative of secant is secant x tangent x. Plus second times derivative of the first. Second is going to be secant x times derivative of the first. Derivative of x is it's 1. And so if you want to rewrite it or simplify it, you can maybe take secant of x out and then be left with x tangent x plus 1. There's a couple different ways to write it or simplify it as far as these go. Questions so far? So now we're taking all of our previous rules and we're applying some trig to it. So let's do a couple more. Make sure that's right. Okay. All right. T squared sine of t. So let's do f prime. Sorry, at prime of t. We want a t in our variable. First times derivative of the second. Derivative of sine. It's cosine of t. Plus second times derivative of the first. Derivative of t squared. 2t. The 2 comes down from the exponent out in front. T to the first. Oh, fourth root of t. Fourth root of t is t to what power? 1/4. Root means a fractional exponent. Oh, so then g prime of t is going to be derivative of t to the 1/4. The 1/4 comes out in front. T to the subtract 1. And we get, if I take 1/4 minus 1, negative 3/4. Plus 8 times derivative of secant of t. Derivative of secant of t is secant of t tangent of t. Most of this chapter is getting comfortable with these derivative rules and just take the derivative. I'm going to go ahead and put the 3/2 out in front. And then we'll do this as the quotient rule. Low. 3/2 comes out in front. There's a 3/2 here. Low is cosine x. D high. What's the derivative of the top there? Derivative of 1 is what? 0. Minus derivative of sine. So derivative of sine is cosine. And so we're left with 0 minus cosine of x. So we're left with negative cosine of x. Minus high d low. High is 1 minus sine of x. D low, derivative of cosine, is negative sine of x. Over the square of what's below. That's better. Keeping the 3/2 out in front. Let's see, this is, I'm going to take the negative out again. And let's see what we get. Cosine of x times negative cosine of x. That's going to be cosine squared of x. minus, or sorry, that's going to be a plus since I took the negative out. Plus, I need to distribute a negative sign. That's going to be 1 times negative sign is negative sign. But then a negative sign times a negative sign is going to be a positive sign squared. Really, what we're doing is we're getting a bit fancy with simplifying with the trig. Cosine squared of x plus sine squared of x is 1 minus sine of x over cosine squared of x. Yeah, I kicked it out. Get out of the parentheses. So the negative will end up over here. If we wanted to, we could split up. We could split this up to be 1 over cosine squared, which is secant squared. Then minus sine of x over cosine squared of x is going to be sine of x over cosine of x times 1 over cosine of x. This is the same thing, which sine over cosine is tangent of x. 1 over cosine of x is secant of x. Interesting. Those look like derivative rules we just looked at. Secant x tangent x is a derivative rule, and so is secant squared of x. Let's take a look at why that is. Let's take a look at why that happens. And I'll do that by showing you rewriting this in a slightly different way. And that is, if we took this idea which I just talked about and do this at the start, this splitting up of the fraction, to split it up into 1 over cosine squared of x minus sine of x over cosine squared of x. If I did that at the beginning, then what I would get is that this part would be 1 over cosine of x minus sine of x over cosine of x. This is secant, this is tangent. Here's derivative of secant, here's derivative of tangent. And I get the same answer. So a lot of times there are going to be different ways to arrive at our answer for these derivative rules. And let's see. Those are the main ones I wanted to get to. So let me round off here. Oh, you should know higher order derivatives. We talked about this notation, right? If we have more derivatives, we have more prime. Okay. Let me tell you what's going to be on the test on Friday. Test Friday, here's what's on it. You will have one problem where you are doing the limit definition of derivative. So f of x plus h minus f of x all over h, and you're going to prove that for a probably a polynomial. That's what we spent most of the time looking at it for. And it should not be an overly complicated one. You should be able to know what the answer is because you know the power rule. So if I give you x squared, you should know that the derivative is 2x. So you already know what the answer is going to be. You just need to show me that that's the answer. So you'll already know if you're right or not when you hit the end. One problem where you're going to get the equation of the tangent line. So we talked about that last week. The derivative is going to be your slope of that tangent line. And then you need the x and y coordinate of the point. You're going to have one problem where you're going to have to relate position, velocity, and acceleration. And know that that's the order that the derivatives go in. Derivative of position is velocity, derivative of velocity is acceleration. And be able to apply that to a question. And then a bunch of derivative rules. The rest of the test is take the derivative of this function. That's the test. So you have a limit definition, you'll have tangent line problem, you'll have a problem where you're talking about position, velocity, and acceleration, how those relate, and then the rest are just take the derivative of the function. So make sure you know your derivative rules. That's going to be the test.